Hello, hello. Yes, we want to welcome you back. Still on the same circuit here. We are winding up with it. The channel is Physical Sciences Silver Bullet, and the voice is Richard. We are not going to get tired of reminding you to subscribe. It is for your own good. Don't even hesitate. Just click that button and everything will be okay. Okay, we are looking at this case. Switch S1 is now closed. Remember previously it was open. So now this one is closed and the switch S2 is now open. So when you open this switch, what does it mean? It means that this resistor is out of the circuit. So opening of the switch makes no current go through here. So the only resistor we have are these ones. So the current flows in this manner. From the positive side, it comes. Here, it doesn't branch because this side is incomplete. So it passes here, and continue forming a complete circuit. So that's what we are having. Now, under the circumstance, when the question says calculate current, what do? You have to be reminded that under the circumstance, you can't use Ohm's law. You are limited by Ohm's law. Let me tell you the reason why you can't use it. You have the resistor, yes. You are looking for current, but you don't know terminal voltage. So you have two unknowns in Ohm's law. The terminal voltage is not known. It is not known because it changes once the circuit changes here. So you don't know VT and you don't know I. Yes, you have the total resistance. So that's a dead end. So under the circumstance, when you're having a dead end, what do? You reach for the general equation, which says EMF is equal to IR, which is going to be I total for this case. Then I total internal resistance. This is our savior this time around. So I want you to remind you something which is very important. That unless you change the battery, this is what is important. EMF and R remain constant for a given battery. So remember, we are using the same circuit, the same battery. So all the things here are changing, but EMF and R, they are the battery, so they are not changing. The only time you can change them is when you take out this battery and replace it with another battery. So what do we see here? We have our EMF, which is 30 volts. Okay. You have our internal resistance. Remember, it hasn't changed also, which is what? 0.75. Okay. And you have even our RT is calculatable. What we remain with after opening this switch are all resistors which are in series. So we are having R1 plus R2, another 1, 2, 3, plus R3, giving you 5 plus 3 plus 4, giving you 12 ohms. So armed with this information, with the E, with the R, with external resistance, then the only unknown in this circuit is I. So when you come to substitute, what are you going to say? You are going to say 30 for EMF, I total, which is needed, times R total, which is 12, plus I total, which is wanted, times internal resistance, which is 0.75. So from here, we are set to get I because it is the only unknown. So let us go through this. So after use of our calculator, we have just found out that I total for this case, when S2 is open, is 2.4 ampere. Then comes the next question. Then comes this question under the same vein when the switch S2 is open. The question says, state what happens to the voltmeter reading V. All together? Yes. State what happens to the voltmeter reading V when the switch S2 is open. That's what we are discussing. So what happens to it requires some bit of explanation. So we are going to just state, and we reserve the explanation for the next question. What I have to remind you is that whatever happens to the resistor here it follows the same trend as the voltmeter. So let us ask ourselves, what actually happens to the resistor when you open the switch? Now, this one, most of the people misunderstand it. They say, but you have removed the resistor. How comes the resistance increases? Yes, the total resistance of the circuit is going to increase once you take out one resistor, which happens to be in parallel with the other. I want you to remind you that the effective resistance of a parallel component is always smaller than the smallest resistance in the circuit in the parallel component. So what I want to tell you is this: you have this one as 6 and you have this one as 7. So in other words, the total effective resistance when they are in parallel is always smaller than the smallest. The smallest here is 7. So which means that once you open the switch, you make what was in parallel to be in series, and that one makes the resistance to increase. And I'm giving you a tip here. The tip is that where the resistance goes is where the voltage reading, the terminal voltage reading goes. So what are you going to say? The answer is increase. And we are reserving the explanation to the next question because that's what it wants. So here is the question. It says, explain your answer to 1.52. In other words, explain why when the switch S2 is open, the voltmeter reading increases. So this one is done in steps, and for the candidates, I would want to warn you that this one has some good marks and you can fetch it. So what do you start with? You start with what happens to the total resistance. What did we say? Total resistance increase. Okay, that's what happens. And we know next aspect is the current. So what happens when total resistance increase? Total current decrease. Okay. After that, what happens? Then here you have to quote the general formula. You say that from the expression, what's the expression? E is equal to Vt, that's what we are looking for to find out how it will behave, equals to IR. From that expression, what do we see? Let us look at this factor and what is its relationship with the current. It goes where the current goes. When the current decreases, this factor will come down, will decrease also. So in other words, this one will decrease. Are you there? And when it decreases, remember we said EMF is constant. So when this one decreases, what is its effect on the voltmeter reading? Voltmeter reading will increase to maintain E constant. And that's what you put. What are you going to say? You say here, the factor IR decreases. So we say from the expression altogether, this expression, the factor IR decreases. So what will happen? Vt will increase to maintain E constant, or to maintain EMF constant. That's what you're supposed to do to get those marks. You have to fight for them. So the next question, still on the same circuit, it will be in the next video because we don't want long videos. So let's go to the next video for the next question.